In the last video, we saw that for the confidence interval for proportion, if you let your n get larger, then your confidence interval gets larger as well, namely your error, and that means your width because they go together. So once your error, margin of error gets larger, then so does the width of the interval get larger. All right, so let's see if the same holds true for the confidence interval for a mean. So we have here the mean x bar, then the sample standard deviation 100, and then we have sample size, and the sample size you can see is changing here. I realize I should have done that in the last video here just to show you the differences here. So what we're really doing here is affecting these numbers n, but I had to change the numbers x to go with it. That way I kept 0.4 the whole time. All right, so let's go grab the calculator. Now this is the confidence interval for a mean. So we go to stat. All right, in the calculator, let's see, we go to tests, and then let's see, we go to 1 prop z interval. Oh, no, I'm sorry. I'm so sorry. We're doing an interval for the mean. Sorry, we're going to go to number 8, the t interval. Sorry. So we have 350, we have 100, and then our sample size we start off with, let's see, is 50. So let me go back, and I'm going to type in 50. And then we'll go to the confidence level. It's 0.95. Just double check that. Yep, it's 95 for all of them. And then I'll go to calculate and press enter. And there we have it, 321.58 and 378.42. All right, now to find the error, remember we want half the width. So let me put that in there. Half the width would mean that I want to take the difference between these two and divide it by 2. So you can write that a couple different ways. I'll take parentheses 378.42 minus 321.58, close parentheses, divided by 2. And that'd be 28.42. And you can write it either as a big fraction bar with a 2 underneath it, or you could, like we did up here, where you subtract then divide by 2, or you can just say a half and then put the parentheses in the subtraction. All right, now we're going to go do it again and again, but changing our n. So let's change our n to 150. So stat, tests, number 8 this time, and I'll remember 8 is a t interval, and we're going to change this from 50 for our sample size to 150. Go down to calculate and press enter. All right, and 333.87, 366.13. Lovely. So I'm going to put that in there. And then to find the error, I just need to subtract the 2 and then find the difference. So let me press enter here. All right, so look, I've got the last thing I entered is kind of up here. So I can just press enter again. And I'm going to go in and change these numbers. So I want it as 366.13. This is probably more trouble than it was worth, but that's okay. You can just type it. 366.13 minus 333.87. Subtract that and divide by 2, and that gets you 16.13. So that goes right here. And now we do it one more time because, 2 times just wasn't enough. So let me go to grab t interval, and then n will be 250, and then calculate. And there we get 337.54 and 362.46. So when I subtract the 2 and then divide by 2, I would get this to be my error, which is 12.46. So you can see that as n is going up, right, as the sample size is increasing, look at what's happening to your margin of error. It's going down. We started off with 28.42 when n was only 50. And then by the time we get to the bottom with 250, nothing else has changed. We're still looking at 350, 100, 95%, all that good stuff. But this interval is much smaller. And you can tell it's much smaller because its error, which is half of its width, is smaller. All right, so just like with the mean, or excuse me, just like with the proportions, increasing your sample size decreases the error, i.e. the size of your interval. They're inversely related to each other, which is exactly what we wrote, right here, that the size and the width of an interval and the sample size are inversely related. And that's because the margin of error is inversely related. So the margin of error and the size / the width, they're the same thing, of an interval and the sample size are inversely related to each other, meaning when one goes up, one goes down. And I just wrote down real quickly what inversely related means in case you'd forgotten, which means if your n goes up, your size and your width goes down, and vice versa. If n goes down, size of the interval will go up. Size / width / your error, because they're all kind of tied related to each other because the error is just half the width anyway.